So this is going to be a little shorter. This is a tour of the HP-75 software development system. This is a top view of the development system. It's got a 75 on top with a metal case underneath. Looking at the front of the unit, you can see it's connected with a ribbon cable plugging into a regular HP-75 port. Looking at the label, this says this is unit 43. So there were at least 43 of these things floating around in 1982, and back then they thought they might be worth $500. The plug-in for the development system uses the standard standard HP-75 plug-in module with the standard springs. I've got this at my desk if you want to take a look at it after the presentation, with a longer PC board in it that they attach the ribbon cable to. These springs, this module's, for anybody that's trying to build something for a 75, is a pain in the butt to deal with. Those springs, those cantilever springs, were specially designed to maximize the number of insertions that you can do. The module plastic was designed for a fairly tight interference fit. So anybody that's used a 75 and pulled modules in and out very much will know that it's painful to do that. We actually built a small piece of aluminum that we used to pull it out when we were doing development. Okay. The back of the unit, this unit uses a standard HP-75 adapter. This is a reset plug. Nothing comes out there. This is the standard developed AC adapter, the 82059B. Nothing special about that. Whoops. This looks like a stock HP-75C, but it's not, and we'll see why later. They're looking at the back of the 75, you see these silver points. Anybody got a guess at what those were for? As it says, those are ESD test ports. So we purposely zapped the unit on some of the metal surfaces during the product development testing to see if it would send the firmware in strange places. The bottom of the unit, another test point. The 75 does have a RAM module in it. It doesn't have a battery. Now, one of the things every time someone talks about batteries for some of these products, I watch is how many milliamp hours. Well, when we were designing for the 75 and later for the pod, the budget for what a classic battery would take is 425 milliamp hours. So when we look at what's in a nickel metal hydride battery these days, or lithium, it's a lot more than we had, and that's why, for instance, in the pod, it took 2 batteries, is because the modem pulled enough current that you had to, in order to get the lifetime that we needed for operating for a pod, we had to do that. So think 425 milliamp hours. That was our total power budget for operating the product. Okay, after you take the 75 off the top, this is what the unit looks like. This is solid sheet metal. This thing built like a tank. You could stand on it and not dent it or shift it. Looking in closer, okay, in the back, you can see that the unit, and I've got a side picture over here. The unit has 5 standoffs. You can see it. You can see it looking in the back. When you take the top off the unit, you can see that there are stacked standoffs. The bottom standoff gets the PC board up off the metal case. You can see the reset. The LED lights up when the power is on, and the top standoff connects to the top case. There's a closer view of that. Okay, you can unfold the unit. The power cable runs from the back of the unit all the way to the front of the unit, and the cable's long enough that you can unfold it without disconnecting, although there are 2 disconnects so that you can separate the top from the bottom. Okay, this is the top case. You can see it, maybe you can get a view of how thick that metal is. And the bottom case. So I've got lots of pictures in here, and I'm willing to do even more pictures for someone if they ever want to try to build one of these themselves. You can see in a few minutes that it is possible.
Can you clarify what the development system does? What is it developing?
It's a software development system. So,
so this is...
So these, well, I'll get to that in a minute. You'll see. Okay, so large view of the PC board. Okay, in the back, these ZIF sockets are for 2 plug-in ROMs. So 4 EEPROMs. You note that, so you've got this, and so this is where, so the system, you ask what's it used for? Well, I'm finally getting around to that, sort of like the old HP profit sharing announcements. That number came last. What these units were for was for plug-in ROM development. So you would develop it on they developed it on the 21MX systems, and then they downloaded it into EEPROM programmers, and then plugged these in, and then you ran the HP-75 system with plug-in ROMs. But it's also set up so that they could develop the OS on it, and these are the OS ROMs for the 75. So I said before that was not a real HP-75, and I didn't say why.
Now you only had one of these, or you had multiple of them?
There were 43 of these units.
Oh, that's right. Yeah.
So these I said that the HP-75 wasn't a real HP-75.
It had no ROMs.
It has no ROMs.
No ROMs, yeah.
So it's empty, and I've verified that on the 75 unit. Okay.
Chuck, were these way early in the life of the 75, like way before the PMS and that stuff?
It was, yes, it was earlier in development. So the Feline or the PMS, the program module simulators, those were used later. Like when we developed a pod, we used the Felines.
So when the 75 was being developed, it was anticipated that third-party development in assembler.
So these would go to third parties, but these were also used for the initial sets of ROMs that were developed.
Well, that's
The math ROMs.
yeah. Oh, for the in-house ROMs. Okay,
Yeah. Okay, good question. Okay, zooming in on the PC board. This is one of the better documented PC boards. Every component on the board has a label to it, which is sort of handy if you're gonna, I'll show you in a second, do a component list. Okay, I zoomed in on the pictures for your references. It's all on the slideshow so that you can see. I had to zoom in so that you could get the 1820 numbers. For those of you that are used to tearing apart HP systems, HP was a volume purchaser of semiconductors, so it forced a lot of manufacturers to put the HP part numbers, and a lot of the ICs were 1820- something or other.
You have one of these personally?
Yes.
Okay.
This is, yes.
Yeah, of course.
Okay, so zooming in on the front side of the unit. Okay, this, I said that all of the components, so you've got PC board pictures with all of the components labeled. This, I went through and looked up all of the 1820 numbers that are referenced, and this is all of the PC board components for the whole unit. And so all of these, I will point out, are standard components. So for those of you that have, I don't know how many of you have used the HP-75 system. The way the HP-75 works is they have something called a memory address register, a MAR, and that interfaces between the Capricorn equivalent bus, that's 75 bus, and standard memory. Okay, that's implemented in this unit, all in standard commercially available components. So that if you look at this list careful, there are no custom components here. So the hardest thing in putting this unit, if you want to build one of these yourself, is duplicating the PC board number one and duplicating the 75 plug-in connector, the module connector. Okay. So if you want to do this, you could do it. As I was dealing with these 1820 numbers, I realized I needed to figure out how to find them. And it turns out that at this link, there is a bench brief that one of the things in the bench brief is a manufacturer code cross-reference. And so this has the HP1820 has cross-references not only for the 1820 numbers, but for a number of other products. This is in the HP archive, which is on your flash drive. So you already have this cross-reference. If you're ever tearing apart an HP system trying to figure out what an 1820 ... is, you've got the cross-reference on your flash drive. Thank you, Eric. Okay, this is the back of the PC board, and even in late production, the PC board wasn't perfect.
Of course, there's always one.
Yeah. Okay, now let's speak to the state of this unit that I have. Okay, now it has been in a fairly climate-controlled environment. Unfortunately, I'm going to show you some pictures that look sort of ugly. It's got what I affectionately call PC board rot, which is this is corrosion on the traces.
Gold-plated?
I thought it was gold-plated, but it's you see rot around the traces, some of the traces, and it's some of the solder points. Some more on the sides here, and here, and here, here, and here. And on the back side of the board, even though it had solder mask on it, there's PC board rot. Now, since I took these pictures, I gave a smaller version of this presentation to the HPCC folks on WebEx, and they said, well, Chuck, what you need to do is take a fiber pin and gently scrape the rot off, the corrosion off. I've done that. The other thing they said to do is well, it looked like, if you go back to the board, and I won't do that in the spirit of time. All of the parts on the board are socketed, and there was a concern that this unit is set for 30 years. Well, you need to reseat it. So I've reseated all of the ICs on the board. I also checked the continuity of traces, long traces like this, at the two ends to make sure that the trace hasn't gone away.
Right.
And I checked the continuity from trace to neighboring trace to make sure none of the traces were shorted. Okay? And the unit still doesn't work. Okay. So it's a work in progress. The next step, I think, is I'm going to need to get a hold of an oscilloscope, because I think I've about exhausted what you can do with a multimeter to figure this out. So it's not done yet. Give me 5 years and I may be back presenting a working unit.
So if you have access to the, I don't know the right term, it's like a thing of water, you put it in and it vibrates.
Ultrasonics?
Yeah, ultrasonic cleaner.
No.
I've heard that, I mean,
That's pretty big
you may know people that in the industry and stuff. I've heard that you can clean parts that are visibly perfect. I don't know enough about it, but I just heard that those would be wonderful. But that's a big board.
Yeah. I've got a small one that I use.
Okay, so at the end, I think it's sort of ironic if you look at these two side by side. This is the development system that we started the HP-75 project with, And this is the follow-on project that we ended up using. This may have been subliminally, this may have been subliminal when we were doing the 75 pod design.
What are you gonna do with it when you get it working? Reprogram it?
No.
Okay.
Right now, I'm retired, I have time. My intention is quite frankly, is to
It's an
go
educational.
through 35 years worth of collection and clean it up and document it for the community. Because I've had access, and you'll see in another presentation, I've had access to some equipment that this group may not see if I don't present it.
Excellent.
Chuck, do you know, were these dev systems used by firmware?
Yes, these were firmware development systems, internal firmware development and other companies.
No, I'm referring to the company firmware systems that made the fourth ROM, for example, for the 75 and a few other things.
Yeah.
Yeah. Okay.
This is used by those internal teams.
So this was essentially the only way you developed assembly-based.
Well, we had Bambi and Feline later, right?
Well, okay, much later. Yeah, you're right.
Yeah.
But you can't do a simpler of those, can you? Weren't those only for basics?
No, I thought you
No,
could.
no.
I thought you could put ROMs in Felines.
I guess but there was like an HP-1000 based cross assembler or something.
Oh yeah. These don't. You can't write code on these.
No.
You can only take code that's been written on the 1000 system, the MX system, download it into proms, and then put it on this thing to let people, beat on it and test it.
You could write assembly with fork.
Yeah, fourth would like it. That's why it was a big thing.
Yeah.
Cool thing.
Okay.
Still looking for it.
Any other questions?
Thanks.
Thank you very much.